Hello and welcome to this video about NetSim. This is one of two videos being made. I recommend watching the other video before this one. Uh, this video will be a bit about how to set up your grid, so how to get a grid up and going in NetSim, and different changes you can make to the grid and how to calibrate the grid and change some things regarding load cases and connecting new consumers and so on. So first of all, this is the NetSim client we're looking at, and this is the grid we're looking at. And we have on the right, we have some tables with the pipes, the nodes, and our consumers connected. To get to this point where this grid is up and running in this way, we usually work with shapefiles. We can also work with other files from GIS systems. So if you can't get shapefiles for some reason, you can always let us know and we can see if we can find some solution. But usually we use shapefiles to get the layout of the grid and also pipe dimensions usually. And then depending on how detailed your documentation and data is, we can also get height information, maybe some pumps and some plants and so on. To get everything up and running with how the grid looks like. After that is done, we usually also import consumer data. So that's usually some powers and temperatures. We can work with generalized return or delta T's if needed, but best case scenario, we have some return temperatures or delta T's measured from your clients together with some form of power. And we usually use a maximum measured power during last year or so, of course with some filters and so on to make sure we don't have any erroneous values getting entered. And these can be made either through shapefiles as well. So if you have in the same shapefile all this information, we can import it that way. Otherwise, we can also import it from Excel or CSV files. And that's, I think, usually the case if you have your GIS data in one system and then you have maybe your consumption data in another system, in a billing system or something like this, where you have some more information about how the usage of the clients are working. And the thing that we normally use there is that we have a common denominator, so a common ID normally between the GIS data and the consumer data. So with all of this, we can get something like this up and running. And of course, depending on level of documentation, there is more or less manual input needed to be made. In best case scenario, we could get this up and running and calculatable straight away, but usually there is some form of manual input needed, and how much it is depends on documentation quality usually. If you have done calculations on your grid before, there's usually much less work to be done. Otherwise, there might be a bit more. And what we usually look for is to make sure that everything is connected properly in a correct way from the GIS data, and also that there is correct inner dimensions for all the pipes, because sometimes there can be some zeros missing or something, meaning that we have huge bottlenecks which shouldn't be there. But usually with a couple of hours of work, something like this, we can get the grid up and running and working from after we have done the import. You can, of course, also draw the grid from scratch inside of NetSim. So if it's a new project, a new grid that you're just starting to plan out, then you can draw it from scratch inside of NetSim as well. And should be noted, this background map we have here can be imported for any grid in NetSim. So as long as you know which coordinate system you're in, this can be loaded automatically for the area where you're working with. So it's a standard one working for on online maps to be downloaded. When we work with NetSim, we can change our load cases fairly easily, and this is usually done for mainly existing grids where you have some data to go back to and look through how your grid has operated during different outdoor temperatures. And to do this, I will just go over to the Simulate tab here. And as you can see, and if you've seen the previous video, you've seen some results from our -15 degrees load case. And you can see that we have a rough estimate of 40 megawatts of production in the north in the production plant 1 here, and then we have 2 megawatts expected in the plant 2 in the south here. And this is for minus 15 degrees. If you would like to change this to see how the grid operates under different conditions, you can change the outdoor temperature to 0 degrees. And if you keep a look here, I will just press the update button and you should see some things change up here. And there are a few changes being made by this. When we do this update, it will recalculate the power usage of the grid. So as you see, we have now 22.8 megawatts instead of 42. Also recalculates the supply temperature. So we had 96.7 degrees, now we have 86.7 degrees. And we will also have a slightly different return temperature. And all of this is based on curves that we use to get this to work. I'll just make a simulation. So if you've seen the other video, you can see a bit how this compares with the load case we had, and also to show you the calculation time we're working with. So if I press run here, you will see that this calculation takes maybe a second or so to calculate. And this is with 300 consumers and a couple of loops. And of course, calculation time will depend heavily on the size and complexity of the grid you're working with. Usually we, I would say maybe 10,000 consumers, we talk about up to maybe 5 minutes of calculation time. And then 5,000 consumers or so, we talk about a couple of minutes usually, as a rough guideline at least. But after you've done this, if I press to analyze here, we will get this result loaded in with our new changed information. So here you have the load case for 0 degrees. And if we put up the legend, we can see that we have these differential pressures here. And in this case, they are not varying that much, and that's due to the fairly low load for this grid. So at 0 degrees, this is at a lower load case, and we don't have that much pressure losses because it's dimensioned for much colder temperatures. But being able to do this and just go to the update button as soon as it's calibrated, then you can easily update it and you can change the conditions for your calculations very fast after the initial setup has been done. And how this is done is through curves. So we have factor curves. So if we take a look here, this is for the return temperature. I'll go over to the power. So this is a power curve, and this will be adapted to each grid as setup is done, something you can do yourself or we can help you with. Usually we do it for you the first setup, and then you can choose to update on your own or let us help again, depending on what you prefer. But this tells us how much of the connected power that we should use at different outdoor temperatures. And since we calculate the grid as a whole normally and not every small consumer on its own, we have a combination of a simultaneity factor here. So that's why we don't go up to a 1, basically, because we don't have all the consumers using their full power at the same time. So we go up to roughly 75% or 74% in minus 20. We had 65% of the connected power usage in minus 15, and now at 0 degrees we have 0.4 or 40% then of the power usage. And we can set up different curves for this if we have different type of consumers. Usually it's a good way to set up this is to have choose a few large consumers that maybe behave a bit differently than the standard ones and make sure they have their own curve. You can also go and categorize them in different ways and so on. However, there is always there's more work. The more of these you set up, the more work it is to both set up initially and also maintain it in the long run. So usually I recommend to not go too heavy on these unless you feel like you have a lot of time to put into this, and how exact the calculations are is extra important for some reason. Usually we get very good results with just a general one and a few select ones for the large consumers. But of course you get a few extra percentage of accuracy if you put even more time into it. And we have the same thing here. We have supply temperature curves depending on outdoor temperature. So in this case, we are running a higher supply temperature to be able to maintain the power in the grid even when it gets colder, to ensure we don't have any issues. So this can be done and set up for each grid and for each plant if you want to have different ones to then have these updates be as easy as possible. We can also connect new consumers. So first of all, what we can do is copy our model. So if we have a setup model, maybe imported from our GIS data, then we don't want to change that one. We want to keep it because that's how our grid looks, but we still want to evaluate how new connections or other changes will impact this. So then we can copy the entire model and have one original using, and then we can have multiple copies of the model where we will make these changes. So if we want to connect the consumer, you can just right click and press add new pipe. And then I can connect it to the grid somewhere. And I will draw it here. In this case, I'm drawing it close to this school because it's a bit provocative. It's, I think, a good idea to see how the grid around it is affected, and it's most clearly visible in this area. So that's why I'm going here. So in this case, we can just fill in the power. So if we want to connect, let's say 150 kilowatts and maybe, let's say 55 degrees return temperature, you can input this as you want, and then we submit this. And then I can also select to choose the size of this pipe, and I can select from available pipe types, which if we do the setup for you, we will make sure that this list is relevant to the pipe types that you have in your grid. Or you can also choose the question mark, which lets NetSim decide how large this pipe should be based on set criteria that you can change. We'll submit this, and you have a new consumer here, and then we will just try to make a calculation to see how this would impact the changes. So I'm going to minus 15 degrees again, because we probably want to see more what happens with this consumer during the higher load cases, at least initially. So I'm going back to minus 15, and I will just simulate this. And I will do just replace our previous minus 15 degrees calculation. Again, calculation is fairly fast. And I will go to the Analyze software, or Analyze tab rather, and have a look at what's happening here. And in this case, we can just take a look. So this is the consumer we connected. If I hover my mouse over it, we see that we have 150 kilowatts and 55 degrees return temperature, which is what we specified. We also have a supply temperature, and this is calculated. So based on us sending out a supply temperature up here, which is 96.67 degrees, we have down here a 95.36. So we lose 1.3 degrees or so supply temperature. So that's calculated by the software, and the return temperature is specified here. And then we also have the flow and pressures calculated. We can also have a look at the pipe here, and we can see that we have, in this case, the N40 pipe connected, and we have a pressure gradient of 128 pascals per meter. So in this case, we're using a velocity criteria of 1 meter per second as maximum. So if we have taken a pipe that ensures we are below 1 meter per second. But this can also be changed between both pressure gradient, so the pressure loss per meter, or the velocity in pipes that is allowed for the calculations of this. We can also see the impact it has down here. We had 0.42 bars in a previous calculation of minus 15 in the other video. And here we have 0.3 bars. So in this case, we will have some impact on this consumer. And since this is the critical area of the grid, then it's very important to evaluate what impact this will have when we do this connection. Okay, I will not talk that much more right now. This is a short video, so I hope you enjoyed what you've seen. And if you want to see anything more, have any questions, you're always welcome to contact us, and we can have a meeting where we can show you a bit more and answer any questions that you have.